Hello, I am Mrs. O'Brien, and this video is about the answers to homework questions from section 14.5. The first question we will look at is number 3, Tyler's flag problem. Tyler has designed his own flag on a rectangle that is 3 inches tall and 6 inches wide. Now he wants to draw a larger version of his flag on a rectangle that is 9 inches tall. How wide should Tyler's flag be? Label the diagram with the dimensions given. Now it asks us to solve the problem in two ways, with the scale factor method and the internal factor method. In each case, explain clearly the idea and reasoning behind the method and link the method to a proportion. So in the internal factor method, we look at internally what the ratio is between the two factors and replicate it in the larger image. In the scale factor method, we compare similar sides to each other. So in other words, to go from 3 inches to 9 inches, the question is what do you have to multiply by to go from the original to the image? And if it is getting larger, then the number you're multiplying by is a number greater than 1. And if the image is smaller than the original, your scale factor will be a number between 0 and 1. Let's look at the first one using the internal factor method. So with the internal factor method, we're comparing the factors within the original figure. It was 6 inches wide and 3 inches tall. So it's 2 times its height, or the flag width is 2 times the height. And we're getting that by going the value of the width divided by the height. So that means that the larger flag will be 9 inches tall, because 2 times 9 will give us 18 inches. If we were to set up a proportion for this method, it would likely be 6 over 3 is equal to x over 9. So I'm doing the width compared to the height of the original and the width compared to the height of the image. And then you can just cross multiply and solve, and you will get 18 equals x. For the scale factor method, we're going to use the heights of both flags because we know both of those values. And since it was going from 3 inches here to 9 inches, 9 divided by 3, so we go the image divided by the original to get the scale factor. So 9 divided by 3 means it's 3 times as large. So this rectangle, its dimensions will be 3 times as large as these dimensions. So I can just take the 6 inches, multiply by the 3 times as large to get the missing value, which is 18 inches. If we were to set up a proportion for the scale factor method, we would do the image compared to the original for the heights, and then we'd set it up the image compared to the original for the widths. And cross multiply and solve, and you'll get the same answer, 18 inches. For question number 5, Kelsey wants to make a scale drawing of herself standing straight with her arms down. Kelsey is 4 feet 4 inches tall. Her leg is 24 inches long. She wants to make a drawing of herself that's 10 inches tall. And approximately how long should the leg be? So again, she is 4 feet tall, or 4 feet 4 inches tall, which is the same as 52 inches. And her leg is 24 inches. So the drawing total length or height, would be 10 inches. They want to know how long the leg should be if we were to keep everything in proportion. So they'd like us to solve the problem in two ways, the scale factor method and the internal factor method, and explain clearly the idea and reasoning behind each method and link it to a proportion. So in the internal method, we're looking at the height compared to the leg, and at the scale factor method, we're comparing the height of the original to the height of the image. So for the first way I did it, I used the internal factor method. And in the internal factor method, we are comparing the 24 inches of the leg to the 52 inches height, which means the ratio of them are 0.4615, or you can keep it as a fraction. So the leg is 0.4615 times the height. So if I multiply this 10 times that internal factor of 0.4615, I'll get 4.615 inches. So that's approximately how long this leg will be. So again, the internal factor is comparing the factors within a one figure, figuring out what their ratio is, and using that to create the same ratio in the image. And if we were to set a proportion up for the internal factor method, we have our original, the actual length of the leg over the height of the person, compared to the drawing length of the leg over the height of the person. And then of course we can cross multiply and solve the proportion that way. The other method we want to look at is the scale factor method. So for the scale factor, to figure out the scale factor, we always take the image and divide by the original. So when we look at our figures, the one thing we know on both of them is the height. So the image has a height of 10 inches and the original has a height of 52 inches. So 10 over 52, if I divide, it gives me a very long decimal. So keeping it as a fraction is actually more accurate. I just reduced it to 5 over 26. So the scale factor is 5 over 26 or 10 over 52. Take the scale factor, multiply by the actual length of the leg of 24 inches, and that will give you the length of the image leg. So 5 over 26 times 24 gives us 4.615 inches for the height of our leg. Now, if you wanted to set up a proportion for this, you're going to compare the image to the original for heights, and then the image to the original for leg length. The next question is question number 6. A painting that is 4 feet 3 inches by 6 feet 4 inches, which I've shown here, 4 feet 3 inches by 6 feet 4 inches. The side, it's going to be reproduced on a card, which I've done over here as the image. The side that is 4 feet 3 inches long will become 3 inches, and then the one that is 6 feet 4 inches is the one we're looking for, so I put a question mark here. So I called the painting the original and the card the image. So I want to try to find the missing length. And again, we can either look at an internal factor between them or a scale factor between them. I converted both of them to inches so that they were easier to work with. Using the scale factor method, I think proved to be the easiest. I took the image, which was 3 inches, and divided by the original, which was 51 inches. That reduces to 1 over 17, and since that is not a nice decimal, I left it as 1 over 17. So the scale factor times the original give me the image length. So 1 over 17 times the original length of 76 inches gives me 4 8/17 of an inch, or 4.47 inches. So approximately 4.5 inches is going to be the long side of the postcard. Question number 12. Sue has a rectangular garden. If she makes her garden twice as wide and twice as long as it is now, will the area of her garden be twice as big? So I made up some dimensions of a original garden that's 3 feet by 10 feet. So it has an area of 30 square feet. If I double 3 feet, I get 6 feet. And if I double 10 feet, I get 20 feet. And that's what it means to be twice as long or twice as wide, is to multiply by 2. So since both dimensions have been multiplied by 2, and now if I multiply them together to get an area, I get 120 square feet. If you compare the area of my new garden, which is 120, to my area of my original garden, which was 30, 120 divided by 30 means my new garden is 4 times as large. You could also do this with just generic dimensions like length and width. And if you double it, it's 2L and 2W. Multiply 2L times 2W, you get 4 times LW. So if the original was LW, then the new one's going to be 4 times LW. Thanks for watching. The images and questions came from our textbook, Mathematics for Elementary Teachers with Activities.